This naturalrefrigerants.com article is being read by an automated voice. ATMO. Europe, Pascal. Outlines low-pressure solid-state Barocaloric refrigeration potential by J.O. Haraldson. Published January 26, 2026. Adam Slavny, CEO and co-founder of US-based startup Pascal, outlined the potential of the company's low-pressure solid-state Barocaloric refrigeration design at the Atmosphere, ATMO Europe Summit 2025. In a presentation, Slavny shared details about the technology, costs, and efficiency. The event, organized by Atmosphere, was held November 24th to 25th in Padua, Italy. Atmosphere is the publisher of naturalrefrigerants.com. When the solid undergoes a phase transition between ordered and disordered states under applied pressure, there is a very large change in entropy, Slavny said. It absorbs or releases heat, with Pascal's materials producing a temperature change of more than 30 degrees Celsius, 54 degrees Fahrenheit, in a single pressurization stage. The technology. The system cycles through pressurizing two thin-tubed heat exchangers packed with Pascal's solid powder material, with one heat exchanger hot at any given time and the other cold. We use a gas compressor, preferably a CO21, to apply up to 20 bar, 290 pounds per square inch. Pressure to the solid refrigerant material, Slavny said, with the on/off cycle lasting from as few as 30 seconds up to several minutes. We've observed a temperature range from -10 to 50 degrees Celsius, 14 to 122 degrees Fahrenheit, on the surface of the tube, he added. For refrigeration, a secondary heat transfer fluid circulates to absorb heat from the Barocaloric solid, transferring it to the ambient air and carrying cooling to the refrigerated space. The startup, founded in 2023 as a spin-out of a Harvard chemistry lab, raised venture funding to develop the technology from Kozla Ventures and the Engine Ventures. Cost/efficiency. We can build the system using roughly 80% off-the-shelf components, Slavny said, which supports cost parity with existing refrigeration technology. The company needs a CO2 compressor capable of operating at 10 to 20 bars, 145 to 290 pounds per square inch, and a thin-walled heat exchanger to increase efficiency, according to Slavny. If you produce compressors or heat exchangers and are interested in pushing the envelope, I want to talk to you, he added. He compared Pascal's solid refrigerant system to a propane gas compression system. Every mole of propane produces 14 kilojoules of energy per cycle, while sending a mole of CO2 over a similar pressure range produces 26 kilojoules of energy per cycle in the solid-state system. However, Pascal's system incurs additional losses, including heating and cooling of the heat exchangers. We think we will net out ahead, Slavny said. By the end of 2026, we hope to demonstrate a 20% energy efficiency improvement over a state-of-the-art compression system. Product development. Pascal has built an integrated Barocaloric benchtop system capable of 0.03 to 0.04 kilowatts, known as 9 to 0.01 tons of refrigeration, of cooling power using air as the secondary heat transfer fluid, according to Slavny. In approximately 90 minutes, it lowers the ambient temperature to a 3 degrees Celsius, 37 degrees Fahrenheit, refrigeration temperature. The company planned to move the benchtop into a commercial demonstration with controlled insulation boundaries by the end of 2025. Although its customers are driving commercial development, Slavny noted, larger applications such as commercial HVAC would provide better economies of scale in terms of efficiency. Quotable. Traditionally, calorics have suffered from very high operating pressures, which leads to thick metal walls and expensive components, Slavny said. Pascal was founded on driving down the pressure, and now our systems operate in a conventional HVAC range.